Okay, so final couple of straight line revision questions. So the first one here, write down the gradient and y-intercept of the following lines. Now, we spoke in the last video about the idea of y equals mx plus c. So the gradient is our m and the y-intercept is our c. So in this example here, hopefully it's quite easy to spot that the gradient of this line would be 2/3 and the y-intercept c would be -4. You might even want to write that as the actual coordinate of the y-intercept, which would be 0, -4. Okay, in this next one, again, it's in the right format. We've got y equals mx plus c. So here again, m is -5, the number in front of the x, and c is just 1, +1, and again, you might want to write that as a coordinate. This next one, we have a problem. Okay, we have the gradient when it's in the form y equals mx plus c. This at the moment says 3y. So what we need to do is we need to get rid of that 3, thinking about our opposites. This is 3 times y, so we're going to divide by 3. But if we divide that by 3, we have to divide the 2x by 3, and we have to divide the +9 by 3. Okay, so that would leave me here with y equals 2 divided by 3 is 2/3 of x, and 9 divided by 3, that one works out nicely to give me 3. Now it's in y equals format. I can see that the gradient is 2/3, and I can see that the y-intercept is this 3, or again, that's the coordinate 0, 3. With a final example like this, our equation looks even worse in that respect. This is 2y plus 3x minus 7 equals 0. Now we want y equals something. So the first things that's stopping us having that is that -7. So we're going to do the opposite. We're going to add 7 to both sides. Okay, so that would give me 2y plus 3x equals 7. Still not helpful. Still got this 3x. So that's the next thing to deal with. We're going to take away the 3x from both sides. Now, normally I would tell you probably to write this as 7 minus 3x on this side, but we're not because we're used to seeing it written a different way. So we're going to write this as 2y equals minus 3x plus 7 instead, because we're getting closer to this y equals mx plus c idea. Final step though, we don't want 2y, we just want 1y, so we're going to divide by 2, divide that by 2 therefore, and divide that by 2 therefore. Okay, remember what you do to one thing, you have to do to them all. So 2y divided by 2 gives me y, perfect, what I wanted, y equals, okay, -3/2, we can't tidy that up any further. You could write minus y 1.5, but you know I prefer fractions, they're much neater, especially when you end up with things like thirds, where they don't divide nicely, you don't get a nice number. Okay, minus 1.5 would be okay in this case. And the same here, I'm going to leave it as 7/2. You could write plus 3.5, you're going to get the marks for that, but we know that fractions are going to be much easier as we go on. Now it's nice and easy. The gradient here therefore must be -3/2, and the y-intercept RC is 7/2, or we could write that as the coordinate 0, 7/2. Okay, and then question 3. Find the equation of the line parallel to y equals 4x minus 3, which goes through the point -1, 5. Now, we've maybe not spoken about this a huge amount. Lines that are parallel have this same gradient. If you think about it, parallel lines, always the same distance apart, therefore they've got the same slope, if you like, the same gradient. So this line here has a gradient of 4, so that line that we're about to work out is also going to have a gradient of 4. Okay, and then we're told that this specific line goes through this point, -1, 5. Okay, this is the kind of question you'll get asked a lot higher as well, but now we can go back to one of the things that we looked at in the earlier video, which is we have a gradient and we have a point that the line goes through, and that's all we need. Okay, you've got two options. We can use the y minus b equals m bracket x minus a equation, or we can use the y equals mx plus c equation. Doesn't matter which one you choose to use, okay? if we're using the y minus b one first of all, then this is your coordinate that you're using, a and b, so minus 1 and 5. So if we substitute that in, we're going to have y minus 5 equals 4 bracket x minus minus 1. Let me just need to multiply that out and tidy it up. So y minus 5 equals 4. Let's just tidy up the double negative inside the bracket first of all. So 4 bracket x plus 1. Y minus 5 equals 4x plus 4. So y equals 4x plus 9 is the equation of the line. Now, just to prove that that's right, or to prove that either method is valid, let's do it this way as well. In this case, we're trying to work out c. We don't know where it crosses the y-axis, so instead of talking about a and b, this time these are going to be our x and our y. Okay, so x is minus 1 and y is 5, and we already know the gradient is 4. So y is 5, the gradient is 4, x is minus 1, and we're trying to work out c. So 5 equals, that'll give me minus 4 plus c, add that 4 across, would give me c equals 9. Therefore, if y equals mx plus c, then y equals, the gradient was 4 and c was 9, and so we've ended up with the same answer, so it doesn't matter what one you use.